Hey everyone! Welcome back to our Smart Chore app series. In the last episode, we kicked things off with project setup and authentication. Today, we're focusing on the database, both the design and its integration into the app. Let's start by thinking about what we actually need. Personally, I don't live alone, which means I'm not the only one doing chores. So, one of the key features of this app is the ability to invite other people into a shared space. Based on that idea, we'll need a way to create one or more spaces. You can think of them as homes or apartments. And send invitations to other users so they can join in and log their completed chores too. Naturally, that brings up the question of roles. We'll need at least 3 rows. An admin to manage the space, a guest with limited access, and maybe a delegated admin, not the owner, but still able to help run things. Inside each space, we'll have rooms, and each room will contain chores that can be assigned, completed, and tracked. With all that in mind, we're ready to design the database. Alright, to sketch out our database diagram, we're going to use a tool called DrawSQL. The link is in the description if you want to follow along. The free tier is more than enough for what we're building, and it's perfect for visualizing how our data is connected before diving into code. Let's walk through the process of creating the diagram step by step. Let's start with the users table. This one's our foundation. Every other table will somehow relate to it. Add a UUID as the ID and make it the primary key. Then a few essentials. Email, password, and full name all as strings. Finally, drop in created @ and updated @ with default values of now. Boom! First table done. Now let's create homes. Each home is like a group or a shared space. Add a UUID of course. A name to label the space. And the important one, owner ID. This links to the user who created the home. Don't forget the timestamps at the bottom. Time to connect users and homes with home members. This is where invitations and roles come into play. Add home ID and user ID, both linking to their respective tables. Add a role column and give it options like manager, member, or even admin delegate. We'll also track invited at whether they've accepted and the usual timestamps. And just to keep things clean, set a unique constraint on home ID plus user ID. Let's move on to rooms they live inside a home. Every home can have multiple rooms. Kitchen, bathroom, living room, you get the idea. So in the table, we'll start with a home ID to know where the room belongs, then a name, and maybe a short description to give more context. And of course, we wrap it up with the usual timestamps. Before we dive into the chores table, let's take a second to connect all the pieces we've set up so far, and while we're at it, let's clean up the workspace a bit so the links aren't all tangled up. Now let's talk about the core of the app, the chores table. That's what the whole thing is really built around. We'll start by linking each chore to a room using room ID. Then we add the title, a short description, and a recurrence field to know how often it needs to be done. And, of course, we drop in the timestamps. Let's go ahead and link this table directly to the others so everything's connected and makes sense. And finally, the chore logs table. This table keeps track of who did what and when. Add chore ID and user ID as foreign keys. Again, don't forget the timestamps, it's really important here. And that's it, we've now got a clean and scalable diagram ready to power our smart chore app. Now that the structure is clear and everything's linked properly, let's bring it to life inside the project. Now that we've got the structure clear, let's actually bring it into the project. We'll use Adonis to generate one migration file per table. The command is pretty straightforward. Nodejs make column model homes -mc and we do the same for each table. Rooms, home members, chores, and chore logs. Since we set up the Adonis project with authentication, it already comes with the user's migration, so no need to create that one ourselves. With this command, we are creating the model, the M flag creates the migration, and the C flag creates the controller, so each time 3 files are generated. But for now, we'll only use 2 of them. the migration and the model. The migration is where we define the shape of our table fields, types, constraints, relationships, and it's fully compatible with PostgreSQL features like UUIDs and foreign keys. The model, on the other hand, is how we'll interact with that table in our code. It acts like a bridge between the database and the logic of our app. We'll use it to create, query, update, or delete records, all with clean, readable syntax instead of raw SQL. It keeps things structured, typed, and way easier to scale later on. Let's walk through the creation of the first migration together, and I'll handle the rest off camera to keep things moving. First, in the up method, we add the name, an optional description, and of course the owner ID, which links to the user's table. You'll also notice Adonis generates the down method for us. That one just drops the table if we ever need to roll back. Once the schema's done, we move on to the model file. Nothing too fancy, just define the fields we've set in the migration. And from there, we're ready to start filling the database with some test data. Good news! AdonisJS has a built-in factory system powered by Faker, so generating test data is super simple. First, we create a factory with nodejs make factory home. Then, all we need to do is complete the return statement. Let's add random names, optional descriptions, and link everything to our first user. Then off camera, I'll set up the rest factories for rooms and chores, making sure everything's connected properly, so our test data feels like a real version of the app. But before, let's do the seeding part. We're gonna start together with the home model, and again, I'll handle the rest off camera. I generate the seeder using nodejs make seeder home. Then, inside the file, all I have to do is call the factory and tell it to create 10 entries. Once that's done, I'll take care of setting up the other seeders and factories for rooms, users, chores, and make sure everything links together properly. We'll meet back here in a second to run all the seeders and check that our database is nicely populated. Okay, so after some work on my end, everything's ready. As you can see, the home model has changed a bit. We now have relationships set up to get the owner, co-owners, and the rooms linked to it. All the other migrations, models, and factories are created as well, so we just need to run the migration and populate the database. Let's run the node acemigration:refresh command. As you can see, everything's working perfectly. Now, let's run the node acedb:seed command. And perfect, everything's good to go. Now, let's check if everything has been created properly using pgadmin. In pgadmin, we can run SQL queries. Let's check if we have users first. Okay, it's looking good. Now, let's see if we have chores. As you can see, everything looks like it's been created. Mission accomplished. In the next episode, we'll start building out the API layer, setting up routes and controllers for all the objects we just seeded. That way, we'll be able to interact with our data from the front end or mobile app and finally start making things dynamic. Thanks again for sticking around. If you're into this kind of dev content, feel free to like, subscribe, and maybe share it with someone who'd find it helpful. See you in the next one. Bye-bye!